Alright, for number 7, this time we're going to use the second derivative test to find relative extrema, which is the same thing as local, which is looking for max and mins. So if you are using the second derivative test, all that means is you have to look at the second derivative instead of the first derivative to make your sign chart. Now, well, you don't even have to make a sign chart. You just have to look at the sign. So if it's concave down, the second derivative will be negative and we'll have a max. If it's concave up, the second derivative will be positive and we'll have a min. So it's kind of the opposite of what you'd think. The maximum comes out negative. The minimum comes out positive. But we still have to take the first derivative. We still have to find our critical points. It's just that we skipped the second derivative instead of making a sign chart. So let's start with the first derivative. Alright, that wasn't so bad. And, well, let's find the critical points first. So critical points, anywhere where the derivative is 0 or undefined, is going to be a possible max or min. So if we set this equal to 0, add 6 to both sides, divide by 6, we only get one possible place, and that's at 1. So we need to plug in 1 to the second derivative to see what the sign is, positive or negative. Well, this one's sort of interesting because when you find the second derivative, you get 6. So the second derivative is always 6, so the second derivative is always positive. Alright? So therefore, the concavity has to be positive. So x equals 1. And so if it's positive, remember, it's concave up, so it's a min. So x equals 1. Well, let me rephrase this. F of x has a local min, or relative min, at x equals 1, because f prime of 1 equals 0